The game, built in Flutter, is made of two screens. The first screen is a landing screen where the players can change the theme, the username, and toggle sounds and vibrations. The second screen is where the actual game is and is transitioned into it beautifully using a combination of implicit and explicit animation widgets along with custom clippers. And a transform widget is applied to simulate rotation in 3D space. The entry animations for most of the elements are done using a custom widget called delayed loader that delays the rendering of the widget on the screen. This makes sure that not everything is simultaneously rendered, making it look very chaotic. The retro 3D effect on the UI elements is achieved using a custom painter that is placed under the container in a stack with a path that surrounds it with spacing in two directions. Using an animation controller, the spacing can be changed to make it look like the container is getting pushed into it, which made the basic structure of the buttons used in this game. The little 2x2 puzzle demonstrating the buttons function was made in Rive along with all the other action buttons. The toggle buttons are all custom made from the default material icons by downloading them as SVG and using Rive to animate their paths and shapes. A very basic state machine was implemented to switch between the toggled states. The same image is passed on to all the tile pieces, and depending on their default position, the images are scaled up, clipped, and positioned with an appropriate offset. Theoretically, any widget can be used to set as tile pieces, but there are several performance limitations with runtime libraries like Rive and Lottie, which have to render all the layers 60 times a second in all the puzzle pieces. So I had an animation exported into a GIF to show as a proof of concept. The solve button sends a standard HTTP request to a Cloud Run instance which is running the puzzle solver. The actual solver, written in Python, is modified from Michael's work here, which uses IDA star algorithm with pattern database heuristics to solve the puzzle as quickly as possible. The background is generated by making small squares using a custom painter and having it wrapped with a transform widget. There's also a radial gradient over the background that changes color and radius based on the progress of the game. The leaderboard system is very simple, which fetches 50 user documents in the user's collection and orders them based on the least amount of time that they have taken to solve. The game responds to multiple types of user inputs to play. The tiles adjacent to the empty space can be moved using the keyboard. With taps or mouse clicks, similar behavior can be achieved, and it also supports dragging and dropping the tiles with additional support for flicking the tiles into the empty space. All of these moves can be performed for multiple tiles at a time when there's enough space for it. Almost every widget has a tooltip for accessibility. The game can dynamically adjust to two different types of screen sizes to account for form factors of mobile devices, tablets, desktops, and laptops. This is the first time I have used so many animation widgets to push my creativity to its limit, and I'm thankful to the Flutter team for hosting this event and giving us an opportunity to tread on uncharted waters. Thank you for watching this video, and I hope you learned something new as well.